In problem 2.2, we're looking at tuition costs at a certain college and kind of observing how they go up slowly over time, or sometimes not so slowly. So specifically in this case, they give us some prices. Hey, in 2012, the cost was $30,000. In 2013, it was $31,200, and so on. They also tell us that the tuition has been increasing by the same percentage each year since 2000. Now, when we get down to this next step here, the first actual question, they give us an equation. C of t equals 30,000 times 1.04 with an exponent of t. And what they want us to figure out is, what does the 30,000 mean? And what does the 1.04 mean? So in this case, the 30,000 is the starting amount. It's the starting cost. Now, for this specific problem, starting means in 2012, because they're using that as their baseline, and they tell us here that it is t is the number of years since 2012. 1.04 is the number that we're going to be repeatedly multiplying by, because that's the one that has the exponent attached to it. So if it's been 1 year, we're going to multiply by 1.04. If it's been 2 years, we're going to do times 1.04 times 1.04, and so on. So that number actually has a name. 1.04 is the growth factor. And all that means is the number we multiply by each time. So in this case, each year. So moving on a little bit. What is the percent increase in tuition from year to year? Well, 1.04 is telling us how our number changes. It tells us we're multiplying by 1.04 each time. And what I'm going to do here, kind of like we had to do in the last problem to figure out where that 3/4 came from, I'm going to break down this 1.04 a little bit. I'm going to rewrite this as 1 plus 0.04. Now remember, 1 multiplied by 1 doesn't change a number at all. So the kind of extra part here, the rate of change that we're dealing with, is the 0.04. And that we can write as a percentage as 4%. Now this is a good time to kind of do a little side note here and talk about this. If you want to find your growth or decay factor, right, the number that you multiply by over and over again, the way you do that is you just do 1 plus or minus the rate of change. So it's going to be a plus if it's growing, it's going to be a minus if it's decaying, if it's going down. So like we just looked at one example, that 4%, I turned that into 1 plus 0.04, or 1.04. Let's say it was going up by 20%. Well, that would be 1 plus 0.20, or 1.2. We can go the other direction. Let's say it was going down by 7% each year. Well, that would be 1 minus 0.07, or that would give us 0.93. And let's say it was going down by like 15%. Well, that would be 1 minus 0.15, or 0.85. Now I want you to notice one thing about these numbers. When the value is growing, these are bigger than 1. And when the value is shrinking, or when it's a decay problem, these are less than 1. That will always be true, and this 1 plus the rate or 1 minus the rate shortcut will always work. So back to our problem. The next question we are asked here is, what does C of 3 mean in this situation? Well, they tell us up above that T is the number of years since 2012, right? I underlined that earlier. T is the number of years since 2012. So C of 3 means it has been 3 years, and specifically it is the tuition 3 years after 2012, or that means that it's a tuition in 2015. So now let's go ahead and actually find that value. So C of 3 equals 30,000 times 1.04 with an exponent of 3. Now this is going to break a calculator out for. I know most of you don't have a graphing calculator, so I want to point one thing out. If you are doing this on your phone, you should do this part first. Exponents first before multiplying, right? Order of operations. So on your phone, do this first. And then when you get that number, multiply by 30,000. So give that a try just to make sure everything works out. But the answer you get should be $33,745.92. That is our price, or our cost of tuition after 3 years have passed, so in 2015. Now let's just do a quick kind of common sense check. They tell us in 2014 that it's 32,448, so we've gone up a little bit higher since then, so our number seems pretty reasonable too. Okay, last part of this problem. Write an expression to represent the cost of tuition in 2007. Now here's the weird thing. This is obviously before 2012, but that's okay. Exponential functions can go backwards. That's allowed. So this is specifically 5 years before 2012. So what that means I'm going to do is I'm going to find C of -5. In other words, what was the cost 5 years ago? Which is going to be 30,000 times 1.04 to the -5 exponent. And again, you can do this on a calculator to find this number, 30,000 times 1.04 to the -5 as your exponent. And again, if you're doing this on a phone, make sure you're doing the exponent first, then multiplying. And you should get as a number $24,657.81. That should be about the cost of tuition for this school in 2007. Oh, and that's actually the answer to part B, is that number right there. And again, we can do a common sense check. This number should be smaller than 30,000 because the tuition should be smaller in the past. And that is what happened here. There is one last piece I want to do here, which is just an are you ready for more problem, which I think is a really good one to look at. Jada is predicting here that because it goes up 4% each year, the tuition will increase by 40% each decade or every 10 years. Well, we can check that pretty easily by figuring out, hey, what happens if I do 1.04 times 1.04 times 1.04 times 1.04 10 times. So we can just do 1.04 to the 10th and see what we get. So if you throw that in a calculator, this will actually give us about 1.48, which again, we can break that down. This is the same as 1 plus 0.48. So in other words, after 10 years, tuition has not gone up by 40%, it's gone up by 48%. So do we agree with Jada here? No, it goes up 48% instead of 40%.